Hello, Professor. My name is Adam Ibrahim. This is a board demonstration for Lab 2 Bitwise Operations. The objective of this lab was to program a board to execute operations, one of 8 different operations, when one of these buttons is pressed. Right now, the board is programmed such that an operation will be executed when the signal that is associated with this button, called key 0, changes to 1. The name of this signal is execute in my VHDL code. So the reason why execution will behave this way is the signal execute is on the sensitivity list of a process in my VHDL program. The way the sensitivity list works is the process will not be executed unless at least one of the signals in the sensitivity list changes. So the process will not actually start until something happens with this button to change the signal that's coming from this button. And on top of that, from the logic in the process, nothing will happen unless the signal that is coming from this button is 1. So when the button is in a neutral position, the signal coming from the button is 1, and when it's depressed, the signal coming is 0. So the process will execute once when the button is pushed down, because signal changes, and once when the button comes back up. And an instruction will be executed when the signal both changes and is equal to 1, which is just a long way of saying when the signal changes to 1. And the signal changes to 1 when the button is pushed down and released. So these are the 8 instructions that this board can execute: and, or, exclusive or, not, shift left logical, shift right logical, rotate left and rotate right. To the right is an encoding scheme for each instruction, so that I could give each instruction a unique name that the board can understand, since I can't actually just put these letters into the board, at least not yet. So the each of these is called an opcode. The opcode is designated by the state of these 3 switches 15 to 17, and each number here corresponds to the same position of switch here. So first 0, switch 15, the last 0, switch 17 for AND, which means currently the instruction that would be executed when I push this button and release it is the AND instruction. And this instruction is done on 2 operands. The first operand is defined by the state of the switches 0 to 5. The second operand is defined by the state of the switches 6 to 11. So for convenience, this is the current state of the switches, 1 0 1 0 1 0 and 0 1 0 1 0 1. So, and these are the expected outputs of each instruction for those operands. So when I push this button down and release it, I should get all zeros. And each bit here, each bit of the output, is going to be displayed on these LEDs, LED R0 to LED R5. So nothing should turn on. And indeed, nothing does turn on. Let's go to the next instruction, OR. And just to demonstrate that point about releasing the button, I'm going to hold it down for 2 seconds, and lights will not turn on until I release the button. 1 1000, 2 1000. And only then do the lights come on. I expected every light to come on. All 6 of the bits in the output are 1. We will now switch to exclusive OR, and I expect to have the same output, so no light should change. And no light does change. Now we will go to the NOT instruction. The NOT instruction, and every instruction from here on in, only takes one operand, and this operand is the first one, the one all the way on the right. I expect some of these lights to turn off. And indeed they do. Does it match? Yes, 0, 1, 0, 1, 0, 1. Next we will do shift left logical. And I expect the same output, and that's what I got. Next we will do shift right logical. And I expect the outputs to change. It should be from the left to the right, 0, 0, 1, 0, 1, 0. Indeed, 0, 0, 1, 0, 1, 0. Next we will do rotate left. And I expect the outputs to be 1, 0, 1, 0, 1, 0, and indeed they are. Next we will do rotate right, our final instruction, and I expect the output to be the same. And the output is the same. This is my board demo. Thank you very much for watching.